Okay, let's go to page 296, and this is lesson 25.5, and this is on permutation and arrangement and factorial. Okay, so let's go to example 25-5. Is in how many ways can n number of people be seated in with a row of n chairs? So imagine these are chairs, okay? And then you have n number of people. So first chair, you have n choices, right? You can choose from any one of that. Now once a person is seated, you have one less person. So the next chair will have n minus 1 choices, okay? And then again you have one less person, so you got n minus 2, n minus 3, all right, until one last chair, you have only one person left to choose, okay? And so in this case, this would be n factorial. Okay, and let's go and do one more example. Okay, let's go to example 25-8. Okay, it says here is a counterpoint that can come up with factorials. How many zeros are there at the end of 103 factorial? So this is equal to 103 times 102 times 101 times 100 times all the way to 1. Okay, so once you multiply, okay, how many zeros? This is going to be a very huge number. So how many zeros are there? Okay. Okay, the way to figure out this is realize that 2 times 5 will equal to 10, and it will give you a 0. Okay, so basically you want to find out how many 2 times 5s are there. But if you notice, in this case, there are a lot of 2s. So there are more 2s than the 5s. So we're going to focus on number 5s. Okay, and so again, each number 5 with a number 2 will give you a 10, which will give you a 0 at the end. Okay, but again, like I said, there are abundant number of 2s in there. So all we have to do is figure out how many 5s are in here. When we figure out the numbers 5s, then we can figure out the number of zeros. Okay. Okay, so each of these numbers, okay, so like this one has a 5 in there. So what you want to do is first you want to do is divide by 5. So 103 divided by 5. Okay, so this will give you 20. Okay. Okay, so there are 20. There are 25s. Okay. Okay. But notice when the 25, when you get to like 25, is equal to 5 times 5. So and 50 is 5 times 5 times 2. Okay. So any multiple of 5s, there will be additional 5s. Okay. So let's go and divide by 25 to find out how many extra 5s that we have. Okay. So there are 4 extra 5s. Okay, for 25s, and so that's it. So answer will be 24. Okay, so there are 24 5s in here, and therefore there will be 24 zeros once you multiply everything up. Okay. Now, if this number is bigger than 125, let's say it's 203 factorial. Okay, in this case, then you have to the 125. When you get to like 125, this will equal to 5 times 5 times 5. So this will give you extra the third 5s. So you have to divide by 125 to get the triple 5s. Okay, get extra 5 from the triple 5. So just be aware of that. Okay, now next thing is when you're doing when you arrange like the chairs. Okay, when you have an n number of objects, when you arrange in a row, the answer will be n factorial. But if you sit in a circle, okay, then answer would be n minus 1 factorial. Okay, because on a circle, you need to use one of them to fix a position from rotating, and then the rest of them you can arrange. Okay, because again, if you look from the book, okay, because when you're saying a circle, you can rotate. For example, you can have an A, B, C, then you can have an A, B, C, which is the same. Then you can have an A, B, C. Right? See that? Okay, so they're all the same permutation or same arrangement. Okay, so again, in a circle, they can rotate. So you need to use one of the item to narrow it down to fix it so it doesn't rotate, and therefore the rest of them would be n minus 1 factorial. Okay. Now, if you have a keychain, okay, if you have a keychain and you arrange the key in here, okay, now you have to do one more step. Not only it's a circle, so you need to have the n minus 1 factorial, but this one, the keychain, you can flip over, okay? And therefore, you need to have the n minus 1 factorial divided by 2, okay? Because a keychain, you can flip it over. You can rotate, you can also flip it over. So you have to divide by 2, okay, to account for the flipping over. Okay, so let's go and do example. Let's go to page 299 and example 25-9. It's how many ways can 6 different keys arrange in the keychain. So there are 6 keys, right? So it'd be 5 factorial divided by 2. Okay, so 5 factorial would be 5, 4, 3, 2, 1 over 2. So this is cancel out. Okay, and so the answer would be 60.